So we officially start and welcome to week 6. So we will have 4 hours now, 2 hours tomorrow. Next week there will not be classes because I have to tell you what is happening. I'm the principal investigator of a European project which is about 3 million euros. A set of European universities, and I'm the principal investigator. So you can see, if I do not do everything correctly, I will not survive. Therefore, next week will be fully devoted to this project. So next week there will not be classes. We will finish the following week, right? So now there will be classes today or tomorrow. Next week, no classes.
I'm saying already your class or?
No, just the classes. No. This is a European project about people of statistics. All people are nerds about theorems, and it is, it is, if you want to know more, it is the new customs hub, European centralized custom hub, which will take place in 2028. In 2028, in Europe, we will have a centralized customs hub. So,
There will be the exam on the 29th.
no, well, we postpone it.
Okay.
We postpone it. We decided together. We decided together, right. Then we have decided to postpone it, so to give the possibility to those who have just arrived to take it easy and not to rush, right. We are gonna have it, but it is better not to rush. Actually, to be as much more comfortable as possible. Then we will have a sort of rehearsal of the exam, so that in the week before maybe we give a sort of preview of what you are going to have during the following week, so that it is not my purpose to surprise you, for example, to give you something that we have never done. No. My purpose is to accompany you to have a very nice outcome. That's my purpose. I have no added value in being rude or in being fierce during the exams. And all those who participated in the competition and in the issues will have extra points. Of course, I already mentioned it several times. I keep mentioning it. And there is a GitHub website which is IDS with MATLAB. I say for those who have never seen it. So in the issues, you can write whatever you like. I'm up to date. Everyone receives an answer, and and everything is tagged. And I've also added a tag for Cuban supernova. Yes. Yeah.
Cuban students.
Right. Indeed. So, in fact, here it is important just that you use your nickname. But during the exam, you let me know what is your nickname so that I can associate your nickname to your full name. Right? So on the other end, these are all files that have to be cloned. Okay. As usual, if you want to be notified about the news, you click on all activities. Now, MATLAB 2026A pre-release has been released. I'm a nerd, so that I have already downloaded it because I want to know what will be the future, what people, Therefore, from now on, we are going to use 2026A, which is actually not very well, not very different from the 2025B. So in this class, we are going to use both versions because there is something that in 2026A does not work, but we are going to see it later. Okay. And one of the main news is that there is this button here, MATLAB Home, in 2026, that did not exist before, MATLAB Home. So if you click this button, if you click on here, then you have all the courses directly, the blog, file exchange, MATLAB answer. So they have actually simplified it, this button here, but nothing sensational or nothing really new. Okay. Now, we start with the 3D plots, right? And then we explore all these functions. So let me do clear all and close all so that we start everything, we start from scratch. Let me also close this one. Okay. If you write pics, in the command line, this is a function that helps you understand the 3D. Just write pics, and this will come out. Right. So, or otherwise, if you want to follow it, you can download these examples 3D. So with this function, then you can do mesh, and then this is the output of the mesh. So the mesh, okay, welcome. So the mesh connects a series of discrete points with a lattice structure, a grid of mesh. And then we will see additional examples later. Now with a brief overview. And now let us see, of course, everything here can be rotated as much as you like. You can have different views, right? So you see, and this function is really useful because it has a lot of throats, a lot of peaks, so it is very nice to understand the maxima and the minima. So, therefore, so this has been created with mesh, with peaks, surf peaks, and this you created the shaded 3D surface, which is this one. You see, it is exactly equal to the previous one, but it is shaded. It is shaded, and therefore it has a color. So, and for all 3D functions that have a color, you can add a color bar, right? So how do you add a color bar? Simply write color bar. Okay? So you can see that this color bar goes from blue to white. Okay, now, okay, the color bar can be edited as you like. And there is a function which is color map editor in the plots. Color map editor. Okay, if you click it, and then here you see you can have a preview of all color map, autumn, you see summer, So you have a preview of all the color map. So you can choose the one that you like. Well, here then you can also modify the color, but we do not go up to this point. Okay.
The color is from which?
Sorry?
The color. It seems like little bit. I mean, there is no definite color, definite separation in the color bar. In the color bar,
Yeah.
there is no definite color separation. You
Yeah.
cannot say this one is green.
No. Is it. What he's saying is that there is no color separation. Right. So there is a gradient. Right. A slow movement between one color to the other color. And in fact, I do like these color bars. I don't know what you think, but they are very effective. So the other possibility is color bar, and then you see, well, or where you locate the color bar and so on and so forth, yeah. And then color map, and then when you give space, and then these are the color maps, the suggestion, okay, and then you apply the color map that you like. Okay, now let us see now function which is called contours. Contours connects the points that have equal height, right? So it projects the points of equal height in 3D contour lines. Let us see it. Contour peaks. Right. So that you can see all these points have the same height, and it is also useful. Well, can you have both? Yes. Can you have both the contours and the mesh? Yes. Mesh, see.
So what is sharp peaks?
Yeah. These let me see. So let us comment it. If we want us to comment it.
No, sharp peaks. What that means in the backwards. See,
What is?
no, I'm saying that there is sharp peak.
Well, no, x is this function here. So what's this function? This is a
Sharp
pre-allocated
means surface.
surface. Yes. So the question. Let me come back to now to the microphone. So the question was: surface stand for surface, and these peaks on the other end. This is a function that is inside MATLAB in order to let you understand how this 3D works. So, can you have both the mesh and the contours? Yes, mesh, see. So this is very nice because you have the 3D, and then at the base you have the contours. Well, I've always found it very, very useful. So, okay, now, so far we have created a function peaks. Now we do it with our function in order to understand the 3D. So, for example, if you have x squared, of course, a square is a parabola, and then minus y squared is the parabola, but it is going downwards, right? So if you mix these two, on one side you go up, on the other side you go down, right? So what do you get if in one part you go up and the other part you go down? You have the saddle, right? The saddle of yours, right? And so let us see it. So you create the mesh grid, so all the possible combination of points in the interval -4 and 4, because you have this grid, -4 and 4, -4, -3.9, -4, -3.8. So you have these all these possible combinations of x and y, and so you create it with the mesh grid, as we have seen. Okay. So these x and y, these are 81 times 81. Why? Because this is the length of this sequence. So for each x and each y, and then you have your coordinate z. Coordinate z, and let us see the mesh. Now you can see the saddle. You can see that this is minus s squared. And so you can see that this is, actually this is x squared. And then you have combined both. Here there is x squared, and this is the saddle. Here there is minus s squared, and so this is the saddle of the horse. Yeah.
What did you call it?
Saddle. And there is, in statistics, there is also the saddle point.
Can you go it in Spanish just for so I can match it?
Yeah, yeah, exactly. What is the other name?
It's like a premium. I'm just going in Spanish.
But the saddle is exactly this, you know. From, yeah. It mixes minus x squared with x squared. So if you have ever thought about it, there are two parabola mixed together in 3D. Because in one way we go up and the other direction you go down. And this is the called, well, now, let me be more mathematical. You know that there are the function in 2 or 3 variables, then you have these partial derivatives, and then you have the Hessian, the matrix of second derivatives. I don't know if you have ever studied these things, but in mathematics, then according to the determinant of the matrix of second derivatives, you can decide whether you have a minimum, or you have a maximum, or you have a saddle point.
Okay. Now I know what the saddle point is.
Okay. Okay, now you have finally understood what is the saddle point. But you have to see it this way.
But I didn't have the saddle drawn in my board when I studied it. So.
Yeah, yeah. Okay, so therefore, you know, everything, it depends on how things are explained. Now you know that this, you'll never forget anymore that this is a saddle point, right? Okay, now let us combine, for example, here, I don't know if I have another example. Yes, sine and cosine, right? So sine x plus cosine x, sine, and then the cosine, and this is what, this is the combination of the two, right? So you see this is the sine here, the cosine, and then, okay, so let us simply, let me run all these things, surf. Okay. Yes. Can you recognize the sine here on this side? Can you recognize the cosine? Yes. So you see, all these 3D are simply a mixture of these two things. It's something that can be very easily drawn, so there is nothing mysterious. So mesh, and now we do it with contours. Mesh C. Okay. You see at the bottom, Now, surf C is like surf, but it has, you know, these lines at the very bottom. Okay, that was our small introduction to 3D plots. We have already discussed, therefore, the color bar and the color map. Now, let us see the balloon plot. Probably some of you have already seen it. Let me close all and do clear all. So we load this file, which is called house tasks. House tasks. So this is the file. This is the file. This is a contingency table. Contains the frequencies with which certain tasks are done within the family. And therefore you have if you do load house tasks, it is inside. It is, yes, it is one of the FSTA, of the 100 FSTA datasets. Right, correct. So it just load one time. So you want to find, for example, a full documentation of all datasets of FSTA? Right. Right. For example, if you write the help of a FSTA function, help FSR, one of the yes, then link to the help page. Okay, and then you go to the documentation of FSTA, where you can find here, this is, you see, this is the main page of the documentation, right? And here, where do you go? Yes. Yes, so that makes me happy, because this means that this page, this entry page is clear. Right, datasets. And then here you find what are the regression datasets, what are the multivariate datasets, what are the clustering datasets. You go to multivariate, okay, datasets. And then here it says how you can load. You load with load file name.txt or load file name.mat. So multivariate datasets. And then you can see here, you can find the list of all datasets. You can see the cities Italy, which is documented here, or cities Italy 2024. Right. You see that everything is fully documented. And this is what happens if you try to load this dataset and then if you do not have the mapping toolbox. So everything is fully documented. Okay, so you keep going, and contingency table. Well, I must say that this dataset has not been reported here yet. House tasks. You can see that because you cannot find house tasks here. This is a bug. Thank you, because this gave me the possibility of seeing that indeed it had not been documented here. House tasks, right. But it will be there by the end of this week. So, and of course, everything you find gives me added value. Because as you have seen, it is impossible to supervise everything with software. It is fully impossible. Even people from Matos, they are 50,000 persons, and sometimes there are bugs. We are a group of 7, 8, 10 people, you can imagine. It is impossible to keep up with everything. So this means, for example, clots. If you do load clots, now let us do okay, load plots, and then you have this data set here. So load house tasks, and then you load the house tasks data. Right. So this is the contingency table. Therefore, tasks inside the family. This is a very old survey because nowadays, of course, it's very different. It's very well. So, for example, repairs usually are done by the husband, or maybe you can find holidays. Holidays are decided jointly. Yes, makes sense that you are a couple. Then, I mean, not just a holiday, just one person decides where to go and the other stays at home. Okay, this goes without saying. However, so what are the combination of values between rows and columns that are most important? Okay. Now let me come back to my layout. So you do balloon plot of your table, and this is the balloon plot. So the balloon plot, you have the color bar that you have seen that is associated with the frequency, and so the size of the circle and the color of the circle both are dependent on the size, on the number of, so you can see these are the yellow are the most relevant combinations. For example, holidays jointly, and then repairs husband, here there is this laundry wife, then insurance maybe jointly. So here you can immediately see what are the combinations of values that are most important. Let us see, for example, the balloon plot of the graph univ 2 series. No, yeah, well, I have to this. Let me change the folder. Yeah, let me see this. So this is the data set that we have seen, the sales of ski and water ski. Well, depending on the data set, you have a particular plot. This has to be said. It is important to be well aware that there are a variety of plots. The plots are very effective. When I do the presentations, plot do play a very important part, and will play a very important part in your future. Because if you can present your results in a best way with plot, surely this is a very important thing. Now, bubble charts. Bubble charts are scatter plots where the marker size depends on the third variable. You can also specify a color gradient based on the fourth variable. So this is an attempt to trick the cart, because you are in 2 dimensions, and in 2 dimensions you want to represent 4 variables. So you have the first 2 variables, the third, which is the size of the circle, which is associated to the third variable, and then you have the color, which is associated to the fourth variable. So in 2 dimensions, you represent the information for 4 variables. Let us see, plot bubble chart. Okay, so we consider the data set of the Italian regions. So these are our regions, and so these are university indicators. Pass rate, enrollment rate, out of region students, and then residents. right? Because, okay, we have very small regions. On the other end, we have regions which are much larger.
How do you explain the column profiling?
How do you explain these variables?
The column profiling. The other one. The profile.
The profile here. The profile here. Here, this is not a time series, therefore it doesn't make any sense.
I mean, how do when I wrote my MATLAB in my computer, only it shows the column and the
Does not show.
yeah, that shows the graphs, the column profiling.
Right.
How do you explain the column profiling?
They are displayed automatically if it is a table.
For me, only it's
No. It is no. You know that it must do it automatically. I didn't do anything. So if you have a table, this is the very nice way to see the table. So you have a very nice preview in a graphical way. Okay, in your computers, can you see? If you now load the regions, you load this table, can you see it? Yes, so it is important that you see it, so you know that it exists, and therefore it must work also on your computer. I didn't do anything. This comes out for free if you use MATLAB. Okay. Yeah. Well, let's see, if you use MATLAB in a version of the last 2 or 3 years, if you use MATLAB 2015, of course, you don't have it. This goes without saying. Well, actually, this is something which is really very, very nice at this preview. Okay. So the function is bubble chart. And now we are going to see the help of this function. F1, learn more, and this is the help. So here let us see the, let us try to understand this help. You see that these are 2 ways of calling bubble chart. You see X, Y, S, Z, or table, and then X var, Y var. Now, have a look, because I want to be sure that you know how to read the help. If you know how to read the help, you go everywhere, right? So here it says, bubble chart X, Y, S, Z. In this case, X and Y are 2 vectors. Okay, and bubble size, this is another vector. In this case, X, Y, and SZ are vectors of equal length, but 3 vectors. Or the alternative way is that you supply a table, you can see TBL, you supply a table, and then if you supply a table, the table already has the variable names, and then simply you specify the variable names of the table. So you see these 2 ways of calling, or as 3 vectors. For example, let us do the first, this call here. And suppose you got it. Okay, we see it later, because I'm very curious how you okay. Okay, so let us do bubble chart. Okay, and here it suggests the different ways. This is the most common way, calling with the table. No, I say no. I don't want to call it with the table. What I want to do, I want to supply 3 vectors. Hello, Giacomo. So I want to supply pass rate, enrollment rate, and residence. X dot pass rate, then X dot enrollment rate, x dot residence. You see that these are three vectors. This is the first vector here, you see, a vector of numbers. This is another vector of numbers. Okay, and x dot resident is a third vector of numbers, right? Okay, so you supply these three, and that's it. Of course, do you have the x label? No. Do you have the y label? No, because you have just supplied the numeric data, and it doesn't have any information about the textual information about, right? On the other end, it is much better to have bubble chart to supply X, the table. And now, if you supply the table, just let me know what are the table variables containing X coordinate. You see how it is simple. Containing X coordinate, and in X coordinate we have the pass rate. So, pass rate. Then, tell me what is the variable which contains the y coordinate, for example, enrollment rate, and then tell me the size of the variable, residence. Okay, of course, here a very big red sign, because of course the parenthesis has to be closed, right? So here in MATLAB, you are fully guided, so there is no possibility of misunderstanding. One moment. Domenico, I'm in a class now. Okay, I will call you later. Thank you. Bye. Okay, and now you can see, Now, look at the small novelty of 2026A. It has these three dots, and then you can expand it. On the other end, this was not, this is, in the previous version, you already have this thing, so, well, you can move, you can do whatever you like, data tips, right? Now everything has been condensed here. Okay. Now, bubble chart with 4 variables, that is with a color bar, and then also with the color bar. So everything is as before, because you supplied the 3 variables here, and then the 4th variable. Why the 4th variable has been written out of region student, otherwise it went, you know, it exceeded the limits, however, yeah, it's same thing. Okay, bubble chart. Okay, now you can see that the relationship between these 2 variables is a positive relationship. The correlation coefficient surely is greater than 0. You can see that our regions have very different importance. You can see the size of the circles. Okay, now we put the color bar, and then here, if you want to be tricky, the color bar, you can also give a name to the color bar. And this was the other reason because why we put this out of region students. So you can see that this is the name of the color bar. So you know the variable which identifies the color, right? Which is completely different by this, what is on the x-axis and on the y-axis. And of course, the final thing that you have to do, you put the text. You put the text, and then here you put names. And names is what? Names is the properties row names, are the names of the regions, right? So you add the text. Okay, Lombardia is a very important region, and then you say here, this is where we are, in Emilia-Romagna. Right. And then here you immediately see that the two regions which have a very, very high value of out-of-region students are indeed two small regions which are located in south of Italy. So you can see the information, the nice information, because here you have shown 4 variables. You have tricked the cards because the diagram is just 2 variables. But here you have the importance of the regions and then another variable. So do use them.
You can see 4 variables in 2 dimensions.
Exactly, 4 variables in 2 dimensions. Right. Yes, it is very useful. Very useful because you have all the and they're very, very easy to compute. Okay, now I show you directly what you want to do. Now you want to create a bubble chart which is geographical, right? So here you see that the circle is associated to added value. So you can see the parts of Italy which have very small added value, and the parts of Italy which are much richer. Right. And then, as usual, well, you can zoom wherever you like because everything is online, so it is the typical thing of Google. Now everyone is really accustomed to it. Okay, and this is where, yes, and this is where we are. Here we are. Well, precisely in this moment we are located here, if you recognize the map. Now, tell me, this plot, you think that is very easy to do? Can I have your permission to move on? Because there is nothing, maybe, so. Here, here you see what you have. You end up with this this is a table that have several characteristics, but what we want to have are these 3 variables: the latitude, the longitude, and the added value. With these 3 variables, you call this GeoBubble chart, and that's it. But you must have this information: latitude and longitude, and of course the associated. Now you see that the added value here is being standardized, and then you can immediately see that the mean. Which number is this? Is 0, of course, 10 to the minus 16. Don't be tricked. These are standardized data values, so they have mean 0 and standard deviation equal to 1. Right. What else? Probably this is something very very easy. Well, you can have also then you can also have a column. So here in the province of Parma, this is the map of flyer distribution. So the persons who distribute the flyers, and so they have to know what is their best path, and then we give them the path to follow. Now, swarm charts. Have you already seen them? Okay. Now, let us see when you have, of course, once again, you have 2 variables, but now x is discrete and y is continuous. You see that x is discrete because is the number of components in the family. 1, 2, 3, 4, 5 is discrete. And then here is the amount spent, right? So let us see it. The file is called plot swarm chart. So let us follow the exercise here, if I have it. So it says load the table loyalty. Now I'm curious to know whether loyalty is, this is a regression data set, loyalty. Therefore, it should not be here, regression data set, and then here you must have loyalty. Loyalty, yes, here this one. So here you can find more information about loyalty. This is JK loyalty, right? So these are 509 observations. So these are the typical fidelity cards data. So you know that in the card, you know the age of the customer, then you know the number of times the person has visited the supermarket, and then the amount which has been spent inside the supermarket. So here it says, okay, record any records with family size greater than 5 to have value 5. So those, okay, they are a very small number, so we set 5. Then create a figure with 2 vertically stacked panels. 2 vertically stacked panels, you see these two. Then the top panel should display a scatter plot, the usual scatter plot. The bottom panel a swarm chart. And then set the x-axis limit in both panels to 0.5, 5.5. You see that the axis limits are 0.5, 5.5. Right. Okay, now you see the code. Loyalty family greater than 5. This is Boolean. No, let me load loyalty first of all. Loyalty. Then loyalty family greater than 5. This is a Boolean. A Boolean. So what do you know? Do you do in order to know how many they are? How many are the families with more than 5 people? Some, of course, some of these Boolean. Okay, here it says loyalty.family, those who satisfy the condition are set equal to 5. So this is a subplot with 2 rows and 1 column, and this is the typical scatter. This is the typical scatter of the 2 variables. If you want, it is fine, but it is here you don't know how many people there are inside here. So you have to enlarge, you see here. Okay, so it is better to let's say, to jitter this data. It is much better to call swarm chart, and swarm chart has the same syntax with the table and then the variables. You see what we have seen before. Swarm chart, the table, and then the name of the 2 variables. So something which is really very, very easy. Okay, let me see. And this is much better because you have jittered this data. You have added a random noise on the left or on the right. Okay, so you cannot control the random noise which is added, but doesn't matter, because you want to see roughly how many they are. And so here the number is around 10. On the other end, the number here is much greater. Okay, there are different ways of showing this plot.
X-axis is discrete.
Exactly.
And y-axis is increasing.
It's continuous. Correct. Yes. Absolutely. Absolutely. And they are very, very useful when the x-axis is discrete. Because there is an additional space, so you use this additional space to provide this additional information. Now, once again, do not underestimate the plots, because the plots are very important to show people what you are doing. Okay, let us see now this same data using the violin plot. Same syntax, you call it, okay, the name of the table and the two variables. Let us see the violin plot. Here is the violin plot. So you see that here automatically has this information, because the bigger is, and then the bigger is the number of units that are inside a certain region. But actually, you see, in my opinion, this is not so good. What do you think? But let us see a boss chart. Boss chart, okay, the boss plot, and lets you understand what are the outline. Yes, you see the outline units. But here, yes, you see that this is the third quartile. The third quartile, you see, is here. Therefore, these are 75%, but you don't know how many they are. So from this boss plot, it is not evident how many they are.
But this is on asymmetric.
Yes, yes, okay, and this shows clearly. Yes, thank you for recalling it. You can see that the typical distribution here with positive skewness. Right, you see that the length of the right tail is much longer than the length of the left tail, independently of the number of components in the family. And now let us see. This is the novelty of 2026A. The rain, cloud, plot. This is the novelty. Yes. Well, I knew that it already existed, but okay. Last week I could not show you because there was not MATLAB 2026A. Okay, now let us see. Of course, now you must have just 2026A. Yeah? So, is the violin plot on one side, and the scatter of points in the other side. What do you think? Well, it could be an additional thing to use. Now, let me close all of them, and now we run the file. We run the file, and then layout, tile all, and then which one do you prefer? We see the different information, because here you don't know anything about the outline observation. The boss plot does, but the boss plot doesn't say anything of the distribution inside. It's just a quartile. On the other hand, this is also benefit, but this is a random jittering. Yes, you see it tries to combine both. You know what maybe I would like to have the possibility of adding the rows or the names of the outlying observations here. You think that it is could be relevant to have the numbers of the outlying observations in the boss plot, or maybe to combine or the boss plot or maybe the violin plot side by side? Okay, please. Let us make a survey inside the issues. Because in fact, we in our group were undecided whether to write a new FSTA function which does it or not, but not clear what to do. No, well, no, it doesn't say what are the outliers. Probably here it will be nice to have maybe the outlier shown with a different color.
And yeah, in the related data, even if it does show the outlier, but we can see that most of the observations are in the lower end, only few observations are in the peak. So we can say that that's our outliers. Why we do this double?
Right.
Because most of the
Exactly.
observations are in the only some
Exactly.
of are peak. So by this one, we can't say anything about the outlier.
Right. Yes. Yes. So if you now we have to collect all the needs. If we collect all the needs, maybe we can write maybe an additional function to submit to the file exchange that could be used by the world, that combines characteristic A, B, and C. So we say the group of introduction to data science has created this additional function that has been put inside the FSDA. Well, this is something that, so when in 20 years' time you'll be able to say, look, I've contributed to do it. Why not? Because at the end of the day, these basic statistics are used all over the world. So then it's better also to know what the Python users maybe have done. You know, it's better to see what the competitors are doing in order to get the best. Okay. Now, let us move now to the scatter plot matrix. So this diagram for just two variables is extended to each pair of variables. And on the main diagonal you can have the plots or other plots. So there are three functions in order to create the scatter plot matrix. Gplot matrix was the very old function. Let us see how it works. So first of all, we load into memory firm. And then xt. Okay, so as usual we have xt and xt. xt, the table, xt, the matrix which just contains the numbers, right? Okay, so gplot matrix xd, and this is the traditional scatter plot matrix with the histogram on the main diagonal. Okay, here you don't have the names, then it's much better to have the names, so it is surely much better to call SPM plot. The SPM plot works directly with the table, and then automatically puts the names of the variables, and so you see that the relationship between wage and seniority, as we have seen, is positive. As seniority increases, wage increases. And also the relationship between commuting time and smart work hours here is direct and positive. Now, with SPM plot, you can decide what to put on the main diagonal. With option this popped box, and here you show the boss plots on the main diagonal, you see. And here in this data set, apart from maybe wage, there are people who have a wage much greater, significantly greater than the others. All the other three variables, apart from this commuting time, this is really a very unlucky person which takes quite a lot of time to go to work, but all the rest seem to behave pretty decently. Okay, then we have options overlay. So you want to have a contour that could be an ellipse, for example, in this case. So you want to see you know, how steep, how, yes, how elongated is the ellipse, and this is an indication of the degree of correlation between the two variables. On the other hand, if it is pretty very much a circle, means that the two variables are not correlated. So this is option overlay that can be a structure. Then look, it is also very interesting function core plot. Core plot and requires econometrics toolbox. Look what core plot does. I call core plot with two output arguments, R and P value. And the very nice thing is that not only it creates the scatter plot matrix and it shows the value of the correlation coefficient in each diagram. Not only it shows the regression line among these two pairs of variables, so you see that no way here there is no correlation among these two variables. On the other hand, there is a strong correlation between smart work hours and commuting time. Well, there is a sort of overlapping in the labels, so let me close it and let me run it again. Let me run it again, so the overlap that there was before now doesn't show up anymore. Then, not only gives this information, but it automatically provides the correlation matrix in table format and the table of p-values in table format. So calling core plot, you have automatically the correlation matrix, the matrix of the p-value for the significant test of no correlation. Moreover, there is this nice option which is test R on. If you use this option, then the correlations are colored. In red the correlations which are significant. So you see, those in black are not significant. Those in red, on the other hand, are significant. So, this is, okay, you see, requires econometrics toolbox. So, it matters everything you pay, in the sense that basic standard MATLAB doesn't have this function. Of course, but we as University of Parma have the full version. So we can download legally any toolbox from aerospatial to whatever, to the medical imaging toolbox, but we are going to see the medical imaging toolbox in the second part. Okay, now the grouping variable. And here you want to group according to education. So here there was A, B, and C, if you remember. So we do what we did before, but group. There is this option group. And then you see that you have, instead of having one box plot, you have three box plots. Where the situation among the three groups seems to be, let us say, for seniority, smart work hours, and commuting time seems very similar. But for wage, you can see that the situation is pretty different in the three groups, A, B, and C. And now look at these at these three ellipses. Well, here with 2026A, our legend does not work anymore. Yeah.
Where is the median in the smart work hours?
The smart work hours. Well, because the median is with the first quartile or the third quartile, so that you don't see it, because it is really skewed, so it overlaps, yes. So sometimes it may happen, so therefore the median is here or it is here, because otherwise it appears does not show up. No, there is, but it is highly skewed in the central part. Yeah, but however, thank you very much for your remark. Okay, so this in 2026A does not work, but however, now I show you it 25B, and this was line 30, this was line 30, right, this one here, so let me run this thing up to 30. Okay. And this is the thing that I wanted to show you. That unfortunately with the 2026B, our nice feature does not work anymore. However, we will have to find out why. And of course, we are going to sort it out. No, there is no, yeah. However, now, let us look at this, concentrate on this plot. You can see that C seems to be very different from A and B. Now, let us look at A and B. So let us say A is very different from B and C. You can see now the slope of the increase for B and C is very, very similar. The increase in wage as seniority increases. On the other hand, those who have the educational level A, they have a slope which is much slower than the other two. So what makes the difference is education level B or C, not A. But it is very interesting actually to show all these plots. For example, let us see the Fisher-Iris data. Fisher-Iris data, now we show with the Fisher, with these three groups. And now this is a bivariate, non-parametric estimate of the density. Also this one, look, is very, very nice, with all these contours. That immediately you can understand the degree of overlapping between the different groups. You can see that this group is very detached from the other two. Well, so everything here is fully clickable. Now, okay. Now we see a very nice thing. Therefore, let me summarize. With the scatter plot matrix, you can have an idea about the relationship between a pair of variables. Then you can see those who are approximately linear from those which are non-linear. The group of units with very similar values, then the anomalous values. Univariate or bivariate, not multivariate. Then histograms or Gauss plots can be placed on the main diagonal in order to have indeed the distributional shape of each variable. Now, okay, we want now to do more, and we want to do, for example, something like this. Can you immediately, even if I don't tell you anything, what is minus 0.43? Yes, the correlation coefficient without the information about the grouping variable. Right. So here it says 0.96, then the overall correlation is 0.96, but inside the first, there is one inside this group, among the black is just 0.32. Here is just 0.33, 32, 33, and here it is 0.79. But if you pull all of them together, then the correlation becomes equal to 0.96, which is wrong. So the overall value is wrong. It's not representative of the single of the correlation inside the single groups. Can you see it? Or, for example, look at this. The global correlation is negative, but inside each group there is a correlation, and it depends on the group. So the grouping variable, once again, is very important. From the analysis of the difference between the overall correlation and the correlation among the different groups, you can tell quite a lot. So, scatter plot matrix. How do you do this thing? There is this option which we called type SPM. Well, we did a sort of brainstorming on how to call this option, and then we ended up with the type SPM. SPM stands for scatter plot matrix, so the type. And how does it work? So type SPM is a structure, and then you can say upper. In the upper part, I want to see the number. So let us see. Here you have the below the main diagonal, you have the traditional scatter plot matrix. Above the diagonal, you have the numbers. Okay, and have you seen the size? That the size depends on the magnitude of the value of the correlation coefficient. So therefore, the larger, the greater is in absolute value, the value of the correlation coefficient. And then you can see these are the two variables. You see, this one and then this one that play the game. Then, for example, type SPM upper, type SPM lower, and then lower. Here you can have numbers. You can have circles. You see, instead of having the numbers, you have the circles. Right, yes. Because the type SPM, so let us see the documentation of it. Oh, well, a very short a shortcut is to do edit the name of the function, and then you go directly inside the function. You go, if you don't want to go to the website, you go directly to a function. This is the documentation inside the function. So the documentation inside the function. Okay, color background, this popped, order. Type SPM. Type of scatter plot matrix, character, string, or structure. The default is full. That is the typical scatter plot. If type SPM is lower, scatter plot are shown just below the main diagonal. So you put type SPM lower. Let us see. Type SPM lower. You see?
Okay, but I mean the previous note,
Right.
we had some under the
Right.
with the node and
Right. And in fact, now let us keep reading the help. Or then, here see. If type SPM is a structure, it is possible to control how the lower upper part of the scatter plot is shown. More precisely, type SPM lowers control how the part below the diagonal is shown, and the type SPM upper controls the upper part. Possible entries are for these two things are scatter, circle, square, and number. Or C number, colored number. But we have documented everything, or none. None if you don't want to show anything. So, for example, oh, hi, good morning. So you see here upper none and lower square, or lower can be circle or whatever colored number. But let us see this one with colored number. I have in memory cities Italy. Cities Italy. No, let me load cities Italy. Cities Italy. And so colored number in the upper part and the lower part none. So there is nothing in the lower part, you see. So it is very, very, well, it is very, very easy, but you can imagine the amount of programming it took to do this thing. Or, when you have a data set with really lot of variables, and then if you do this SPM plot, let us see this one, called SPM plot with these 12 variables. A moment that it comes out, it is very cumbersome to see all these scatter plot method because it 12 variables. Well, here you can see, for example, the pair of variables which are negatively correlated. You see that this one is non-linear relationship. You see that it is non-linear. But here, and then look at also the labels. The labels do overlap. Yes, there are so many things. And then you have salary A times 10 to the 4th, then salary A, maybe if you restrict it, then it overlaps, you see. That is not shown anymore. So what you'd like to have is, first of all, a background color. A background color for each scatter, which tells you whether the correlation is positive or negative. Right? First of all, this is the first thing that you'd like to have. Then, you want to have maybe to truncate the labels, maybe just to 4 or 5 characters, otherwise they overlap. Then, the third thing you'd like to have is to have a sort of grouping of the variables so that all that have a positive correlation are shown maybe on a particular part of the scatter plot matrix. Those who are positively correlated. Okay, let us do, for example, SPM plot cities Italy, and then here we use option color background. Color background true. Color background true. So you have a background color for each pairs. Okay, here it is. So you can immediately distinguish those who have a negative correlation from those who have a positive correlation. But the order of the variable here is the order which is given inside the data set. You can have any order, you can have the alphabetical order, or you can have an order in such a way that all the variables which are positively correlated are put together. You see this point? Now, and this option which is order, and then this which is documented inside SPM order. Let us do order of the variables in the scatter plot matrix. Alphabetical is alphabetical order. The order in the input variable is preserved. This is default. Then the order which depends on the first two eigenvectors. Note that here I'm typing in LaTeX, because then when you see the HTML, you show it in proper output. For example, help SPM plot. So let us go to the help function. Okay, so you can if you want, you can install it locally. Okay, SPM plot, and then you can see order, right? Yes, now you can see that it is shown properly. Yeah? Then we say what is the purpose of tangent, what is the purpose of the eigenvalues of eigenvector. Well, they always have a very important part, as we will see also in the final week. However, order A, O, E, this thing, here it says I want to have the upper part the number, the lower part scatter. Then I want to have color background is equal to 2, is equal to true. Then I have an order in such a way that it groups the variables which have a positive correlation from those which have negative correlation. Then name while length has been written by the person who has just called me 20 minutes, this person from the European Commission. That okay, now let me run this code. Moment. Okay, and this is the order. Okay, now you can see that the variables which have a positive correlation are here, and you can see all the correlations. Can you see these numbers? Can you see that this very, very small number, these protest and bankruptcy, these are the amount of failures in firms, and these, the number of bankruptcy and protests, these things have nothing to do with income, because fraudsters can be rich or poor, doesn't matter. It is not that with rich people, I mean, the number of frauds is smaller, not at all. And these are the two, when you see payment in 13 days, employment, deposit, added value, you see that all these variables have a positive correlation, but have a negative correlation with Loisy and urban fragility. So you see these two variables, urban fragility and Loisy, are positive correlated with them, but are negatively correlated with all the other variables. So you see that you have been able to separate, and this is Italy. With one plot, you have shown what is the reality of our country. Yes, it is amazing. And then you also have the correlation here. Look at this number. These numbers, the smaller they are, the negligible is the correlation. Don't you think it is amazing to have this information? And you see the color bar. So the blue are positive, the red are negative. Well, I think this plot is quite nice. I don't know what you think. Let us see, for example, yes, with this grouping variable, the Fisher iris. Okay, that we have already seen it before. Okay, then everything also is clickable here. Right. Okay, let us move on. And the heat maps. Probably you have already seen the heat maps. Is also here there is this gradient of color. And it is important to show patterns for one of both variables. Okay, let us now we have this file rain, heatmap example. Heatmap example is the file. Okay, now we can close 2020, we can stay just with the 2026A. So close all and clear all. Okay, all go away, right. Okay, so we load the rain. Rain automatically loads into memory 3 objects. Load rain. This is just it's not an FSDA dataset, but it is inside the book. Rain is 12 by 5. So probably you are not clicking here in variables. Because this is just a matrix of data, and then you don't see, but you must have a table, of course. If you have a table, these things show up. But if you have just a matrix, then you don't see anything. Okay, so this is our basic data set. It is clear, look at these raw numbers, or on the other end, look at the associated heat map. Is a completely different thing. From the heat map, you can immediately see the pattern. You see that the months and then of daily precipitation distribution. And then look what you see, look that indeed this referred to the months, summer months. Goes without saying. This is 255, means that in these 21 years, there have been 255 days where the precipitation for January was smaller than 0.1 millimeters. Therefore, these are the months from 1 to 12, and on the other end, from 1 to 5, these are the classes. The information about you have RONAM, that is the months, and colNAM are the information about the classes. So therefore, heat map, and let us see the help. Heat map. So you see, heat map once again can be called in 2 different ways. Or you supply a table and then the 2 variables, or otherwise you supply X value, Y values, and C data. And this is what is done here. colNAM, RONAM, and the matrix of the data. If you do this way, you get a matrix which is 12 by 5. You see that the 12 months, then the 5 classes. What is nice here, one nice thing of MATLAB is that this can be moved. This is something, well, what they've been able to do, that you can move each variable. Look, that it is not easy to program something like this. But everything can be moved, and with all the other languages, or also you see, all these things can be moved. Now, so if your X is 12, is a matrix which is 12.5, the heat map is 12.5. On the other end, if the input is a table, for example, with 1,000 rows, if the input is a table, it takes as the unique values of the entries of the rows. You see? Okay, understood? So it is 12 times 5, and then shows a map which is 12 times 5. Let us see an example about the returns. about the returns. Here I cut it short, so you end up with this table T. Okay, so you see this is a table, and this is shown appropriately with the okay. In this table here, we have shown the classes of the returns on investment. Okay, so the number is 1013. Will you display in the heat map the 1013 values? Not at all. You just display the unique values. So these are three very important firms which play a very important role in the Italian economy. Fineco Bank is a bank, then Eni, probably everyone knows what Eni is for the extraction of oil, and then Generali is our main insurance company. Now, and then here I say from T, I take variable 2 or variable 3. Look at the different way. Instead of putting the number, instead of putting the labels of the columns, here I put just 2 and 3, a different way. So you see T, and this is the heat map which comes out. So you see all the classes, and then you can see immediately what are the classes which are most frequent. Once again, one plot much better than 1000 words. Okay. Now we start again at 10:45. Enjoy the break.